Let's talk about the concept of the t-distribution. So here I'm looking at the Rossmann chance applet where we can sample from a normal population here. And what I'm going to do is just take a sample of size 10, one at a time from this population. And what I want you to do is look at the standard deviation as we go sample to sample. Eventually we'll be calculating the mean, but we need to figure out what's our plus or minus margin of error going to be, and that will depend on how spread out things are, which is standard deviation. Since we don't know the population standard deviation, all we can go by is the sample standard deviation. Now look at this very first sample I've collected. This has a standard deviation of 2.95. So that severely underestimates the spread of the data. And you can see it's because we have these points that are all pretty close together, not as spread out as the population. In our next sample, we're also below 5. It's closer, but still below. This one's a little bit over. Now watch the standard deviation as I draw these samples one at a time. So it's under, over, under, way under, over, way under, over, under, over. And as I go, what you'll see is more often it is under than it's over, and it has the potential to be severely under the standard deviation. So we get some as low as 3 or 2. I've even seen, a standard deviation below 1 when I go through these. So it's more common that we underestimate the standard deviation than overestimate it. We are also going to find that as sample sizes are smaller, this effect is even exaggerated. So when I have a sample size of 3, I'm going to frequently be way under that standard deviation of 5 because these 3 points have a tendency to cluster together in the middle, and then that's going to reduce the standard deviation by not including the most extreme observations. Now if I increase my sample size to like 100, I'm actually going to be really close to 5 each time, and I'm probably a lot less likely to have that skew of underestimating it more often than overestimating. It's going to be about an even chance of underestimating and underestimating the standard deviation. So kind of putting all that together, that's why we need this t-distribution. And the t-distribution is a family of curves. We take the normal distribution and we kind of tie it to the idea of degrees of freedom, which is n minus 1. You'd think, why not just use n here? It's only off by 1, but it kind of ties together with, for example, standard deviation being divided by that n minus 1 as well. So in Staplets, there is a t-distribution calculator. And what we would do is put our degrees of freedom first. So think about your sample size, subtract 1. Let's say we have a sample of 25. Then I would want 24 degrees of freedom. You would want to calculate a value corresponding to an area. And then for confidence intervals, we keep a central portion, and that is our confidence level. So if I want to be 95% confident, I'm going to keep the middle 0.95, and that gives me my 2 critical values. Now the notation is alpha over 2. So alpha is going to be the complement of the confidence level. If I have 95% confidence, alpha will be 5% or 0.05. Alpha over 2 will be 0.025. And so in this t-distribution, I could do a left tail of 0.025 and get the left side one, critical value, or I could do a right tail of 0.025 to get the right critical value, or you can do the central area and use the confidence level. So there's kind of 3 different ways to look at it, all giving me the same values. I can include the normal curve as a dashed line. So you're going to see that the black line is slightly higher on the tails. That means it's stretched out a little more. Let's say we look at an extremely small sample of 3. That's 2 degrees of freedom. You can see how much we stretch it out. So we really kind of are using the fact that we're probably underestimating the dispersion or the deviation from the mean. So we're going to make things deviate more from the mean to counteract that, to kind of correct that error in underestimating it. It's kind of a complicated process in theory, but when we do the work, just a couple steps here to find those critical values. So now with 2 degrees of freedom, sample size of 3, you can see my critical values have inflated quite a bit from where they were before. Now I'm at about 4.3, and with 24 degrees of freedom, I was at 2.1 rounded. We usually do keep about 3 digits on that critical value t. Once you know your critical value, it's actually just calculations that you can do in a calculator to get your margin of error and to get your confidence interval. But I'm going to do those in a different video and show you other methods as well.